let's talk through some bell work. On bell work here today, we are graphing these characteristics. So the graphing itself should be pretty easy, okay? Sketch the graph of a rational function with the following characteristics. First thing we got is an intercept at 0, -2. So 0, -2, boom, there's my y-intercept. Vertical asymptote at -2 and 3. So that's a vertical line right here at -2 and at 3. I have a hole at -2.5, 4. So -2.5, 4. I'm going to draw a little open circle right there because I'm going to have a hole. Horizontal asymptote at y = 0. And the graph crosses the horizontal asymptote at 1, 0. So 1, 0, boom. There we go. All right, so there's the attributes. Now I'm going to make the graph. Okay, remember we're split up by the horizontal or by the vertical asymptotes. On the left side of this first asymptote line over here, show me with your arms, what do you think that graph is going to look like? It's going to do something like this. It's going to get close to this horizontal asymptote, but it's not going to cross it because we said it only crosses right there. So we're getting close but not touching. We're going to go through that hole, and I know I got to go through that hole, and I'm going to get close but not touch. So I'm going to go through it something like that. Cool. In between the two vertical asymptotes, so between -2 and 3, I've got to use those two intercepts. Show me their arms. What do you think the shape is going to be in between? It's got to be some sort of S-curve looking thing. So I'm going to start down here. I'm going to S-curve up through, and I'm going to finish up there. Okay, because I know I have to go through that x-intercept. I know I got to get close to the vertical asymptotes, but not touch them. And the only shape that's going to give me that is kind of an S-curve. And then we've got one more section after that vertical asymptote. And you might have done this wrong. You don't really have a lot of guidance here. But since this last one ended up here, where do you think the next one's going to be? Do you think it's going to be above or below that horizontal asymptote? It's going to be below. Okay, and we'll explain that today, but most of the time they alternate. We ended up here, then we started down here. Then we ended up here, then we start down there. That's my shape. Anybody got questions on that one? Great. Now let's write the equation. F of x equals... I got to write an equation for that. All right. So you're kind of going backwards here. We've got the information. Now we're going to write the equation. What is something that stands out that I need to write into my equation? Aaron, what do you think? Vertical asymptotes. I have a vertical asymptote at x is equal to -2 and x is equal to 3. What am I going to put in my rational to get those vertical asymptotes? Good. I need x plus 2 in the denominator. Okay, that's going to get me a vertical asymptote at -2 and an x minus 3 in the denominator. That's what's going to get me x is equal to 3. Excellent. What else? Lydia, what do you think? The hole at 2.5, so I need that in the top and the bottom. Excellent. So to get it at 2.5, I need 2x plus 5. Yeah. 2x plus 5 on top and bottom because that's going to get me a hole at -5. Wonderful. We needed that. I've got an x-intercept at 1. Talk with your neighbor. How am I going to get an x-intercept at 1? Where do x-intercepts live? X-intercepts live in the numerator. Okay, x-intercepts are in the numerator. So what else do I need on top? X minus 1. Cool, I needed that as well. I got a horizontal asymptote. I've got a horizontal asymptote at 0. Okay, so I got to mess with degrees, so I got to check my degree. On top, what's your degree right now? Show me the fingers. What's your degree? It's 2. Show me the fingers. What's the degree on bottom? It's 3. Am I going to get a horizontal asymptote at 0? Yeah, it's bigger on bottom. So that one, boom. We didn't even have to do anything for that one. We just automatically had a horizontal asymptote there. If I want to be really mean, we would then look at y-intercepts. My y-intercept right here is at -2. And so when am I going to get -2 when I do what? If I plug in 0. So these two things are canceling anyways. So if I plugged in 0 right now, on top I would get -1. And on bottom I would get -6. So what would have to go on top for us to get -2 as my y-intercept? Oh, just like everyone said, the answer is -12. Yeah, because if I plugged in 0 on top, that would get me -12. If I plugged in 0 on bottom, or if I plugged in 0 on top, I would get 12. If I plugged in 0 on bottom, I would get -6. That would get me my answer. And that actually fixes my hole as well. Let's try it. Let's go to my calculator. Hit y equals. I'm typing in that fraction. So alpha F1. We're typing in that thing. So I'm doing this from memory. But -12 was on top. X minus 1 was on top. 2x minus 5? 2x plus 5. Thank you. 2x plus 5 was on top. On bottom, we had another 2x plus 5. We had an x plus 2. And the last one was x minus 3. Okay, thank you. X minus 3. Let's hit graph. Oh, yeah. Look at that. Just what we drew. Even got the y-intercept right. Let's go. Okay, we got everything we needed by working backwards. Okay, that's pretty challenging to be able to work back and forth like that. But if you can do that, you know what's going on in this chapter. If you can do what we just did, you understand everything that we needed to get through. Okay, and we'll practice that some more because it's a little challenging. Questions there? All right, let's go to our notes from yesterday. Pull those out for me. Where did we stop on this problem right here? We had x-intercepts and y-intercepts. Did we do vertical asymptotes? We did hole. Okay, so we had a hole on this one at x is equal to 2 because we had an x minus 2 on top and bottom. And we really can write the whole ordered pair here. 2 comma what? How can I find the y value? Plug it in. You got to plug it into the factored form. Because if you plug it into the original, you're getting 0 over 0. Okay, that's why there's a hole. You plug it into the original one. You got to plug it into it after I've canceled out these x minus 2. So if I plug in 2 on top, that gets me 4 minus 1, so it'd get me 3. If I plugged in 2 on bottom, I'd get 4. So 2 and 3/4. So I'm going to draw an open circle right there at 2 3/4. Vertical asymptote at x is equal to -2. Vertical asymptote at -2. Horizontal or oblique? Show me with your fingers. What do you think the horizontal or oblique asymptote is going to be on this graph? Show me with your fingers. I'm waiting on answers. I don't want just 4 people to answer me. I want everybody. What is true about the degree on top and bottom? They're the same. So since they're the same, we're looking at leading coefficients. So it's a 2. So we can draw a horizontal asymptote at 2. I erased these from earlier, but I have an x-intercept at 1/2 and a y-intercept at -1/2. Where do you cross horizontal or oblique? So we are taking, I'm going to take this simplified version because it's just easier. 2x minus 1 over x plus 2. And I'm setting it equal to what? 2, because that's my horizontal asymptote. It is 2, so I'm going to set it equal to 2. Multiply both sides by x plus 2. That's going to cancel. 2x minus 1 equals 2x plus 4. I'm going to subtract 2x. I'm going to add 1. I get 0 equals 5. Does 0 equal 5? No, that's garbage. So what does that mean? You don't cross. You do not cross this horizontal asymptote. It is a horizontal asymptote that we don't cross. It's not always true. Here it is. So we could type this into our calculator. I'm just going to use my brain. Hey, I got these dots right here. Okay, so I'm guessing that my graph does this. We go through that dot, through the hole, that way. And if that one's down in this section, when I go to the left side of the horizontal or the vertical asymptote, where do you think I'm going to be, above or below it? Above. Because if it ended down, the other one's going to start the opposite way. There's my graph. You can back it up with your calculator if you don't believe me. Questions on that one? With your neighbor, I'm going to give you a couple minutes here. Do the next one. Put all that together now, all the different things we've learned. Talk with your neighbor, get that whole thing graphed for me. Go. So we are factoring or simplifying first. So Aaron H., how'd you factor this one? Good. So what were you left with? Good. 3x and x minus 1, and then on bottom? X plus 4 and x minus 3. Good. We're going to try to simplify. Do we have any holes on this one? No. Nothing cancels on top and bottom, so there's not going to be any holes. You can use either version from here on out. You can use the factored or the non-factored. Whatever makes it the easiest for you, do that version. Okay? My next one, I'm trying to find X and Y-intercepts. So if I'm trying to find an X-intercept, Megan, what do I do to find an X-intercept? Set the top equal to 0. So she's taking 3x and making it 0, and x minus 1 and making it 0. So she has two different X-intercepts, 0 and 1. 0 and 1. Those are my two spots. Then we're going to find Y-intercepts. Haley, how do I find Y-intercepts? You plug in 0 for x. So if I'm doing Y-intercepts, that version might be a little bit easier. If I plug in 0 into this, what am I going to get? 0. If I plug in 0 there, that's 0. That's 0. Oh, I get negative 12. What's 0 over negative 12? Oh, guess what? My Y-intercept is 0. We already knew that. Okay, it was already there from the one before. Can you have more than one Y-intercept? Tell your neighbor, why can you not have more than one Y-intercept on these rational functions? Kendall, why can't you have more than one Y-intercept on these rational functions? Yeah, if I had two Y-intercepts, it's failing the vertical line test. Bad, don't do that. All right, then we're going to find vertical asymptotes or holes. Show me the fingers where your vertical asymptotes or holes going to be. You take the bottom, you set it equal to 0. Vertical asymptote at x is equal to negative 4 and positive 3. Negative 4. Positive 3. Find horizontal or oblique asymptotes. Show me with your fingers. Where is your horizontal or oblique asymptote on this one? Your horizontal or oblique asymptote is at 3. Horizontal asymptote at y equals 3 because the degrees are the same. This is x squared, that's x squared, so I look at leading coefficients. It's 3. Cool. Then we figure out where it crosses. So we're going to take, I'm going to use the original one because the original one's a little less clunky. 3x squared minus 3x. And on bottom I got x squared plus x minus 12. What do I want to set that equal to? 3. I'm going to set it equal to my horizontal asymptote. Okay, so I'm going to set it equal to 3. That means I got to multiply both sides by x squared plus x minus 12. Yucky. It looks really bad. It's not going to end up being that bad in the end. So I do that. That's going to cancel. I get 3x squared minus 3x equals 3x squared plus 3x minus 36. I'm going to move the 3x squareds over, so they're going to cancel. I'm going to move this 3x over, so I'm going to get negative 6x, because I'm subtracting it over, equals negative 36. So x is going to be equal to 6. So on my horizontal asymptote, okay, my horizontal asymptote was at 3. On that horizontal asymptote, I'm going to have a intercept when x is 6. So I'm going to cross that line right there. You can cross horizontal asymptotes. It's totally fine. Now let's look at the picture of this thing. So break out your calculator. You guys didn't tell me this yesterday, but you guys don't have most calculators. You can't hit alpha and link. You just got to have a cool calculator like me. Okay, if you don't have a cool enough calculator, then you got to go alpha F1 and then click the N over D button. So we're typing that in, and then we're just typing in our problem here, 3x squared. Is it minus 3x? Minus 3x on top, and on bottom I get x squared plus x minus 12. Cool. Hit graph. Boom, boom, boom. Just like I thought was going to happen. Okay, I had those two vertical asymptotes at -4 and 3. That definitely makes sense. Right here it gets a little ugly. Okay, we had an x-intercept at 0 and 1. Oh yeah, it looks like we might have just barely crossed that thing, and we did. Okay, and then we cross this horizontal 1, 2, 3, 4, 5, 6, like right there. So just for a second we go below it, but then we're going to get right back to that line. Okay, so let's draw a picture of that. No, let's draw a picture. So I'm here. I'm below. I'm cross, back this way. And then I'm up here. I'm going to cross right there, but then I'm getting pretty flat because it's a horizontal asymptote, which means I'm going to be close to that thing as we continue. Questions on that one? All right, let's get back to what we did in bell work. So this is a skill you need to have. Write the equation of this rational function given this graph. Okay, so what we did in bell work, we're going to do the same thing. Talk with your neighbor. Identify the characteristics of this graph that we're going to have to include in our function. Okay, so for a second, just list some stuff out. What do we need to know about that graph in order to write the equation? Go. Herman, what's something about that graph that you think is going to be needed to be written into my function? Yep, vertical asymptotes, that's definitely important. At x is equal to what? -5 and 2. Good. Vertical asymptotes at -5 and 2. What's something else that I need here, Sophia? Horizontal asymptote at y equals 2. Yep, absolutely. We got to include that. What's something else here? Ella, what's something else I got to include in my graph? Nope, x-intercepts. What do you think on x-intercepts? Okay, so we have one at -2 and at 5. Good. Anything special about one of those x-intercepts? Which one? -2, right there, we touch. Don't forget about that. It's been a minute, but we can still do that. Cool. We've got a y-intercept at 2. We'll be able to see that as well, but a y-intercept at -2. Let's see what we can do. Here we go. Now we're going to write that stuff in. So Eli, what is something I need to write in my equation to make sure I include those attributes? X plus 2. Where's an x plus 2 going to go? In my numerator. X plus 2 in my numerator. Because of that right there. But it's got to touch. So what else do you think I got to do with that x plus 2? I got to square it. It's got to be touched. So I got to square it. Matthew, what else do I need? Where's that going to go? Numerator. That's an x-intercept. X minus 5 goes on top. Cool. Need that too. Max, what else?
X minus 2.
X minus 2. Where's that going?
Denominator.
Why is that? Vertical asymptote. Vertical asymptotes live in our denominator. X minus 2. Cool. Did that. What's something else here? Abby, what else do I need? X plus 5 in our denominator. Need that vertical asymptote. Doing pretty well here. I haven't done this one yet. Horizontal asymptote at y equals 2. Aaron?
Take the numerator times 2, and then we have to figure out a way to add another x to the bottom.
Great answer. Horizontal asymptote at 2. If our horizontal asymptote's at 2, what does that tell us about our degrees? They have to be the same. So we have the same degree on top and bottom. That's what we know from that right there. And so Aaron said, all right, we got to throw a 2 on top. Okay, because that's the only way we're going to get it, by a leading coefficient. But then she went on to say, I've got to figure out another way to get an X on bottom. Can I just throw an X on bottom? No, because if I did that, then 0 would be a vertical asymptote. I can't just throw a random 0 on bottom. Okay, I can't put like X minus 3 on top and X minus 3 on bottom, because then I'd have a hole, and I definitely don't see a hole. And so I can't add anything, but I got to do something else. Look at this graph that I gave you and think about the things I've told you. Is there something about those lines that look a little bit different than something I told you would happen? This one right here goes down, and then the one on the other side also is down. If that is happening, the only way that could happen is if your vertical asymptote of 2 is squared. Okay, if you start down and then, or end down and then start down on the opposite sides of a vertical asymptote, that means that vertical asymptote is squared. That's the only way that thing is going to happen. Now is my degree the same? Yes, and I'm going to automatically get that y-intercept in there as well. You can double check me, but you're going to get an y-intercept of 2 in there as well. That's going to happen. Kind of makes sense what we did there. It's a challenge, but it's a good challenge, because if you can do that, you can do everything else we can do. Okay, let's do one more of those, because I know we're not probably perfect at that yet. So you can put this anywhere. I don't really care where it goes. If it's on your bell work, on the notes somewhere, I don't care. Okay, but with your neighbor, here's another problem up here on the board. Try and decide what the equation for that function would be. Go. Yep, let's do it anyways. Here we go. We are writing an equation for this thing. You can give it whatever name you want. F of x is my favorite, so I'm calling him f of x. Check. What's something that you included in this graph? Negative 4 and 2. So what did you have to write into your equation to get a vertical asymptote at negative 4 and 2? Good. X plus 4 and an x minus 2 in the denominator. He has his vertical asymptotes in there. Boom. Okay. I want to go. What else do we need? There's a hole at 0. What did you include to get a hole at 0? Mm-hmm. So we want a hole at 0. I want it to be at x is equal to 0. So we're going to put x on top and bottom. We need it to be the same factor on top and bottom. So since it's at 0, you could write x plus 0, x minus 0 if you'd like to. But just x is going to get us what we want there. Good. We need that on top and bottom. That's going to get us the hole at 0. We'll worry about the value at 1 later on. Just don't overstress about that yet, because it'll come out in the wash here. Okay? I'm not going to make it that hard. Cool. We got that. Sam, what's something else I need here? An x-intercept. I've got an x-intercept at 3. How am I going to get an x-intercept at 3 on that thing? X minus 3 on top. Wonderful. Sam, what else do I need here? Yep. Good. X plus 3. So we're talking about that spot right there. We got that as well. Anything else we need? I think we got it all, right? We got horizontal asymptote. My horizontal asymptote's at 1. In order for there to be a horizontal asymptote at 1, what has to be true about the degree on top and bottom? They're the same. Are they? Yay. And then the leading coefficients would have to get me 1. Would my leading coefficients get me 1 here? Yay. We're good. Okay. We got everything we wanted here. We are done. That one's good. Make sense on that one? I'm not going to make you do this one, but just look at this one real quick. What is something that stands out about this one, about something that perhaps I keep saying, that you would want to include here? They both go down. So at x, at what would it look like? At x plus 5, what would it be? It would be squared. Since this one ends down and then starts down, that's what you need to have. Okay, here's what I want you to do. You're breaking out that homework assignment I gave you yesterday. You got 10 minutes left in class. You're going to work on that now. Okay, if for some reason you already got it all the way done, my last class had some people all the way done, then work on that example on the board and see if you can do that. If you don't get to that, that's perfectly fine. I want you to get done with your homework assignment first and make sure you know what's going on. But if you're just sitting there bored, then try that. Okay, work on it. You got 10 minutes. Call me over. I'd love to help you. I'll come around and give you some assistance. Go to work.